Hello again. In this episode of Dynamic Machine Podcast, I would like to talk about cobots and robots. What are the differences of robot and a cobot, and what are the benefits of using cobots in the workplace? What changes is needed to take place if you equip your production line with cobots? Let's review it together. A cobot or a collaborative robot is a robot intended for direct human-robot interaction within a shared space or where humans and robots are in close proximity. According to the IFR, there are 4 levels of collaboration between industrial robots and human workers. Coexistence. Human and robots work alongside each other without offense, but with no shared workspace. Sequential collaboration. Human and robots are active in shared workspace, but their motions are sequential. They do not work on a part at the same time. Cooperation. Robots and humans work on the same part at the same time, with both in motion. And the last, responsive collaboration. The robot responds in real time to the movement of human worker. So one of the application of cobots is coexistence. As you see in this example, as a case packer, a robot or a cobot, in fact, is applied to take the cartons and make it ready for the packaging. So as you see, there is no really shared space between the human and the cobot. Of course, there is no fence around, but still the cobot do the job. And if there is another application of coexistence, it could be palletizing or just pick and place. As you see in this example, the packaging comes by the conveyance system, and then the robot at the end, it will hold up the packages and put in the cartoon. Another example is palletizing, as I said. So in this example, again, the pattern of the palletizing can be defined easily by the operators, and the cobots can pick up the packages from the conveying, and based on the pattern that is defined, just put them on the pallet. And again, there is no fence around this system, around the cobots, and but there is no, in fact, shared workspace between the operators and the robots. The second category that belongs to collaboration coexistence, it's like that the cobots and the human share the same workspace, but their motion are sequential. It means that they don't share any don't work together on the same part, but it's like sequential, as it was shown in this video. You see that they are actually collaborating, but on sequential motions. It means that the human do something, and then it gives that to the cobots, and cobots tries to do the next steps. The third category belongs to cooperation between cobots and the operator. As you see in this video, there is quite simultaneous task on the same part, and a shared workspace between the cobot and the human operator. So anything can be finished as fast as possible with the collaboration of two sides. An interesting study was done by the Collaborative Robotics Laboratory of University of Coimbra. As you see in this video, there is a very nice example of responsive collaboration that the cobots tries to avoid collision with the human operator. And this is one example that the motion of the cobots is responsive to the motion of the operator's hands. And the collision avoidance can be totally seen with this example. There are differences between a robot and a cobot. A robot is an autonomous machine that completes a task without a human control. Robot does not share workspace with human workers and lacks mobility and flexibility. Robots has almost no perception rather than vision, cannot adapt easily if the process condition changes, and requires sophisticated reprogramming. Robot is expensive and requires expertise in programming. However, it is capable of high payload carriage and more accurate route planning. On the other side, Cobot is an artificially intelligent robot that performs tasks in collaboration with human workers. On the other side, Cobot is mobile, flexible, and agile, and processes steps that are dangerous and difficult for human workers, such as deburring and polishing. On the other side, cobots can utilize a variety of sensing technology, such as motion and force, by the workers and can be equipped by high-end vision computing. Cobot is cheaper and it can improve the productivity of SMEs workers by handling precise tasks at low cost. And cobots also improve the working condition of the workers and brings their satisfaction. Workers can deploy and teach cobots without any external help. Power and force feedback sensor built in. Internal and built-in force feedback sensors work based on current or voltage variation or measurement. The accuracy of built-in force feedback sensors is around plus minus 5 to 10 Newton. The accuracy of external force feedback sensors is around half Newton. Internal or external force feedback sensors can be used for trace kinetic teaching. With a force feedback sensor, such application can be done: hand quitting, weighing stuff, repeatable force, object location, constant force. One of the cool things about programming the cobots is the flexibility and user friendliness of that. As you see, in the free drive mode, based on different type of orientation, you can decide even in the Cartesian mode or planar or custom made mode. You can teach your cobot easily by just grab it and move it. And all this motion now is based on Cartesian criteria. But still, you have lots of chances in the HMI or graphical interface of this cobots to adopt the way or the type or the method of the movement. And it's so easy. You can just grab the tool of the cobots and move it around and define the positions that the cobots needs to reach. Another thing is that there are possibility to restrict this motion. For example, if you need to point your cobots to a specific surface or to a specific position, there is possibility, and you can easily adopt the cobots to concentrate on a specific target. For example, as you see, the TCP or the point of the tool is actually focused on a specific location, and the rest is so easy to program the robot just by motion. This is very interesting, and it is only dedicated to the cobots, and robots unfortunately cannot have such adaptability and flexibility.